Good afternoon. Hello, everybody. Let's just have the last talk. Let's give a quick round of applause for everybody who's been presenting today and putting on the conference. Chris, Brandon, Kickstarter. Yeah, awesome stuff. So, Chris gave a little bit of an introduction, but I wanted to say one more thing. This month marks 13 years that I've been writing Cocoa. I started writing Cocoa in 2002 to contribute to the Adium open source SIEM client. Yeah, go Adium. Worked on that for about 5 years, and then I ended up working at a number of different companies, including Apple. Spent some time at Mozilla, Yahoo. Yeah, so let's get started. Right, so what am I going to talk about? You may be able to have guessed from the title slide there, but I'm going to talk about book, the structure and interpretation of programs, concept from it called stratified design. And then I'm going to try to apply some of those ideas to some common patterns that we face when we're writing Swift and Objective-C with Singletons and then ViewControllers. And I'm really glad I went after Chris because that makes it much easier to talking about. Anyway, all right. So let's just jump right in. Ratified design. So in 1980s, these two MIT professors wrote this book called The Structure and Interpretation of Computer Programs. And in it, they developed this functional Lisp called Scheme. You may have heard of it. And kind of the core idea of the book is this one up here. Excuse me. It's that complicated systems should be defined as a sequence of level designs where you implement each higher level in terms of a lower level. And we're going to go through exactly what I mean by that, but just try to digest what they're saying here in this quote. In particular, pay attention to the three areas that you're going to want to look for if you're doing this sort of pattern, this stratified design. You're going to want to look for primitives, means of combination, and means of abstraction. So what does that really mean? Primitives are just simplest entities that the language is concerned with. We'll get into some examples in a second. Means of combination are going to be compound entities built from these primitives or from other compound entities. And the means of abstraction are going to be ways to turn elements into abstract names and manipulate them as units. So the classic example of this is the Lisp programming language itself, right? For the primitives, we're going to have all the literals like numbers and strings and stuff like that, and also symbols, which similar to symbols in Ruby, and any built-in functions. We're going to have ways to combine them. The primary way is this const cell, plus 1, 2, or applying, any function to its arguments, looks like that. And that's where the list in list processing comes from. And then for the means of abstraction, we have lambdas. We have ways to name a parameter, operate it with it as a unit, and we can also define just names in the environment as well, just this, like lets in Swift. Maybe another example, so to show how this isn't just about programming languages, we can look at arithmetic. So primitives here are going to be just our integers, or rationals, or whatever. We can combine them with operations that we find. Taken just like any sort of advanced math course, you might recognize these as from abstract algebra. And then for abstraction, it's not just functions. We have any of these sort of more abstract binders that encapsulate a pattern, like repeated sums or integrals. Those are also ways to abstract out code and work in sort of a higher order way. Now, what's really key is that these means of abstraction need to be closed under the means of combination. But what I mean by that is that any way you can combine symbols, you can also pass to these abstract entities. That way, you're not going to say, well, I can't handle this type of data in this function. because it doesn't support that. So that's a really key property that we're going to see when I get into one of the examples from the book, just to, again, try to make this really concrete so you have an idea in your head of what it is we're talking about here. So here's an example from the book. They developed this sort of picture language. You can think of it kind of like core graphics. So the primitive here is you're going to be able to draw this little, his name is Wave. He's waving at you. Hello. And so here's these, some ways to combine the two waving people, into these different entities. And we've given them names, and see here we're using wave 2 in the definition of wave 4. We can get a little bit more complicated. We can iterate and split this waving guy up sort of repeatedly iterate this corner split thing. And you can see the definition that they give here. And this is all just totally from this textbook. So, we're iterating over this one, counting down, recursive call to ourselves here in corner split. And, that gives us the image here, kind of this repeating structure there that you can see. And we can get way more complicated and do all sorts of higher order things like this. You don't need to understand what this is doing. Just like getting to this from just a simple set of primitives, like putting two things next to each other, or splitting up a frame into different windows like they were doing, you can do quite a lot. And that's hopefully you're able to follow this intuition. So there's another place where this sort of layered design comes in, and that's actually in UIKit. We have this UI trait collection class, and so the primitives here are going to be trait collection with display scale types of things. And to combine them, we have trait collection with traits from collection. And that will take our primitive traits and make one sort of combined collection with all of those different sets. And then we can use that to do queries and other sorts of things. Is there a means of abstraction for trait collection? Do we have some way to take a set of traits and them as a unit, or sort of define them in terms of other traits? Not really. Maybe someday. Maybe somebody can figure out how to do it as a library. That would be pretty sweet. Okay, so that maybe you're thinking that's fine for Lisp. Like we have these nice lists we can kind of iterate over. We can kind of do these cool little tricks. But how does this work in Swift, right? We're all here to learn about functional programming in Swift, right? So in Swift, this is something that's called the interpreter pattern. So you basically just describe using like an enum or something, inert data, just simple types that say what sort of plan you want to execute, and then you write an interpreter that recurses over that plan. And again, it's closed over the means of combination, which are going to be encoded in your enum or your set of structs or whatever. And these can be as simple as calculating the max of something, or even implementing a Lisp. You can also write multiple interpreters for the same data. So you can think of things like pretty printers or serializing data. And this is a pretty powerful technique. And the way I like to think of this is separating policy from behavior. So you're saying what to do and how to do it in two different places. And that way, when you need to say different things, you don't have to repeat yourself over and over. You can just use the data and write these higher order transformers and combinators. Chris actually in his talk right before mine had a number of really great examples of this sort of combinator-based approach to doing programming, as did Brandon in his Lens talk. So that's sort of the introduction to stratified design. You have these primitives, means of combination, and the means of abstraction. We saw this interpreter pattern, which is how we can realize this sort of thing in Swift. And we'll get into a little bit more what that means as we talk about some of these individual sorts of areas of design patterns, the design space that we face in app development. Okay, so let's move on to singletons. Singletons, I mean, I don't really know if I can call them a pattern, because most people will probably say they're an anti-pattern. You don't want to do them. They're full of global state. And worse, I mean, again, this is functional programming, right? Like, we hate global state. But it's not just an ideological thing. They also, excuse me, completely wreck our test isolation, right? So anything one test case might do that mutates the singleton, it's going to show up in subsequent test cases. It's much harder to do things. But I think they keep showing up. Like, people keep writing singletons for some reason, right? There's got to be something that's good about them. People aren't stupid. They're going to do things that are advantageous to them for some reason. So maybe we can try and figure out what that is. And we'll also look at a couple of alternatives to singletons. And I'll even propose one of my own, maybe it's a little bit harebrained, but I'll let you guys decide. So let's look at one of those right now. And I don't claim to know as much about dependency injection as Veronica. But so I've seen this pattern, which is where we use default arguments to set up sort of a do dependency injection for a singleton. And so what this is just going to look like is, if you want to use a global instance of the singleton, you just don't pass any arguments. And if you want to use some sort of local test instance, then you just pass it in there. I guess probably you'd need a manager thing at the beginning, but that's fine. So this is the end of the story, right? We can move on to the next section. We're done. There are some problems that I want to talk about. And to be clear, these are not insurmountable problems. These are just sort of downsides that I think we can do better than. So with a lot of dependencies, this is going to scale pretty poorly. You know, if you have like 7 arguments to your initializer, like, that's kind of difficult to deal with. You also need to manually inject that dependency that's injected to you to anybody you create that also needs that. Otherwise, your program is going to be referencing 2 different instances under test. Does that make sense? Like, if we don't have, if some object we create just uses this global instance, it's going to do mutations and reads from that instead of the test instance that we created. We also have to remember to use this self.bean manager thing. Because if we don't, again, we're going to be not using our injected dependency and be thing using the global one. And if we don't do that, our program is going to be inconsistent when run under test, which is the worst kind of, I think, testing problem, because it just means spurious test failures. Correct code that your test thinks is wrong. And that makes everybody doubt the value of testing. It's really annoying to deal with. So these false negatives are a really bad thing. So let's return to what I was saying earlier about singletons and whether or not, if we can figure out why people still write them, even though they're supposed to be bad. And people are like, don't do it, horrible, why would you do that? At least, maybe I'm just speaking for myself. I know I still sometimes tend to write singletons. I know I shouldn't. Well, I mean, they're convenient and they're really simple. Like, you're able to assume that there's always something out there that you can get. If you want to know, want to count beans, like, you can always do that. It doesn't really matter where in your code base you are. I don't actually think that this is an invalid thing to assume. There are some pieces of your application, since it only does one set of things, it's not going to do everything. There's just logically going to be some data that's going to need to be accessed from everywhere. I don't think that's an unreasonable thing to want, especially when you start to talk about separating your application into different modules or libraries. So to me, this seems like we're thinking about our code as a language, right? A set of combinators and abstractions that form a kind of little programming language. This would be some sort of an effect in our language that we can always read from this thing, and it's set up for us behind the scenes. So let's try to think of a characterization of singletons that's an ambient effect rather than a global state. So instead of having one instance that is the entire history of the program, we always have some instance available. And we relax the restriction on only having one always. So the first thing that comes to my mind is just to make this global instance a stack. And we can get the current one, we can push, we can pop, and we can also need to be able to initialize our beam manager now too, because we have to do that to be able to push. We have to create a new one. So now already we're one better than a singleton because we're forced to write our class as if it wasn't only initialized ever once. So this is going to help us with our testing. We may have already had to do that to do our tests, but this is going to make it, we're already starting to see some benefit, I think, from going down this road. But I think this still suffers from a similar scaling problem as dependency check. If you have like a whole bunch of different singletons in your app, and okay, maybe that's not the greatest thing, but it could happen. You may need to do some coordination between them. Make sure to like always push two things together. Make sure that things don't get out of sync with each other, and that can get a little bit hairy. So I wonder if there's an even better way. So again, if we think of programming languages, and think about the concept of an environment. This is something that's right out of this SICP book, and the idea is that we're going to group all of this ambient information that we need to access together. In other Lisps, you would call this dynamic scoping, if you've heard that term. So what that's going to look like in Swift, we'll have our app environment struct. We'll have our beam manager and other instances as lets. And then we'll just have some simple code to manage pushing and popping the environment. Now, one thing to note here is that we've removed all of this singleton static stuff from the beam manager class completely. So it is now totally ignorant of the fact that it is a singleton. There's only, and it's available anywhere in the program. That's all here in this effect that we defined. Again, I think this will help you write better code. It'll make those singleton classes less gnarly looking and weird because they have to assume that they could be multiple ones could be created. They could get changed out any time. It forces you to think through how to write more clear code. So in a test method, to kind of go back to what we were sort of originally positing as kind of a problem here, well, we just can wrap this test method in a push environment, pop environment pair after creating a new environment, maybe even having a like extension that creates a brand new test environment for us. That's clean. But we can use lexical scoping here to reduce bugs, and this is just kind of a cool diversion. So we can write this with environment function on the app environment struct, and this thing here, this scope, is just a closure it's just going to invoke with that environment pushed onto the stack, and once that function is done running, it's just going to pop. And it is possible to write an asynchronous version of this. It's similar to a lot of other continuation passing code where you get back a callback to call when it's time to pop the environment, and you just call that in your like final completion handler if you had a bunch of asynchronous calls. Another cool thing about this, as I alluded to before, is that you can define multiple environments for different parts of your code, different modules, or even different classes or whatever. You can also make use of access controls to limit which modules can see the environment. So for instance, to allow people to configure the initial environment and set up all your instances and stuff. Just to build there. But you wouldn't have to necessarily allow the current environment to be read for people outside the module. So then you're isolating sort of your global or your ambient state, protecting it from getting mutated, because you may have mutation methods on those singletons. Fine. You may not want that to be changeable from outside your code. So this ambient nature of the singleton, rather than its global state thing, I think I'm asserting that it's useful. And the environment struct or pattern or whatever that I've defined keeps this ambient nature cases of testing, other sorts of things. But I want to point out that what's really valuable here, what sort of the thought process we went through and how we could see from thinking of our program as like a little language or sort of a level, we can kind of think about where best to put things. And instead of just saying, well, we'll just have this instance floating around, if we think about it more in terms of sorts of levels and implementing sort of a primitive, I can read from any set of configuration parameters that are accessible anywhere, we can write better code and get to better abstraction. The other thing I want to talk about is view controllers, and Chris talked very brilliantly about one way to sort of structure view controllers, and I want to take a little bit of a different tack here. I want to sort of address this idea of the mega view controller, which you may have. Andy Matuszak, my friend, did a really great talk about refactoring this, where he like live coded sort of breaking this huge view controller up into a whole bunch of different constituent parts, and he ended up with like over a dozen individual structs and classes at the end of it. Check it out if you haven't seen it. It's really great. It's refactoring the mega view controller. And I'm also going to ask, like, what are view controllers, and try to figure out sort of what responsibilities they should have, and go into a little bit of where you might want to be coming from, thinking about what sort of stuff should go in these classes instead of, everything. So that's really the nature of this mega view controller, is that it's just sort of a catch-all place to put stuff, right? Like, it's almost like a page class in your app where you just sort of say, yeah, when this thing loads, just start doing stuff. Set up all these views, load from the database, make a network request. Maybe I'm the only one here who's written code like that, but I kind of doubt it. Fundamentally, the problem with this is that these objects aren't reusable at all. Like, you have one screen in your application, and if it looks similar to something else, you have nothing to hang your hat on to try to like share code between. You just start breaking out individual pieces, trying to find abstraction boundaries, and that's you're kind of groping around in the dark there. You don't have anything to sort of help you along the way. And I think that's because when you write code in sort of this, we'll just do everything and did load and view will appear, like I've done, it creates this huge web of dependencies between all these different pieces in your app. And specifically, I think one of the trickiest ones for addressing the idea of reusability is talking to other view controllers and how we do that. Specifically, I think of this as view controllers become coupled at arm's length to each other, because they're not really like tightly integrated, but nevertheless, they actually are totally freezing each other's interfaces. So let me explain what I mean here. So let's just look at a really simple case where we're pushing a view controller in code, right? So we do that other view controller and we initialize it, and we do whatever configuration logic we need to do to set it up, and then we do self navigation controller, push view controller. And so, yeah, we've hard-coded the class and we hard-coded the navigation controller, but I think the really problematic stuff is this stuff in orange here, because this gets duplicated in every other client of other view controllers. They have to do the same setup work. And this means now you have two problems. You have, if you're trying to add additional clients, you have to duplicate code. Put this everywhere you want to do that. And if you're trying to make other view controller more generic, well, all of those other clients also have to duplicate more setup code, more customization, initialization stuff. And so there's just a really strong pressure not to make usable view controllers when they're creating and initializing each other in this way. And I think all this really applies, for the most part, to UI storyboard segue as well, regardless of if you're doing prepare for segue, or you're subclassing and looking in the before method. Basically what you do is you ask source view controller and destination view controller and pull some stuff off those as properties and set some stuff. At least that's the most straightforward way to do it. So I think that run into a lot of these same problems, even if you're using storyboards. So it's not just about hard coding classes, it's really about that orange stuff. So what would it look like to have like a decoupled view controller? Like things that they're not like sort of enmeshing with each other and sort of having this implicit thread that you have to follow as side effects. Well, first of all, they would forward events, like Chris was talking about, instead of performing an action. Instead of saying like, oh, I tap the add button and then I make a view controller and push it, you would sort of return somewhere to some delegate or in some fashion, the add button was tapped and let somebody else decide what to do. You also should assume very little about the outside environment, like you're not in a navigation controller, maybe in some sort of presentation context. You may even be embedded inside another view controller. So trying to write things that can be used as a component rather than sort of a atomic unit that kind of takes over everything. And ultimately, this is all about this point I've been hammering on about reusability and configurability, which really sound a lot more like a view than a controller. And I'm going to assert that we would all be better off if we thought of view controllers as part of the view layer rather than the controller layer. Treated them just sort of like view objects that happen to go together with these navigation controller view objects, and then we control them from outside, from some other system, rather than putting all our code inside it. So the natural question you might ask is, where does controller code go then? I will respond to that question with my own question, which is, what is a controller? So here's a diagram from the Apple documentation. This is what I think I thought a controller was. It's a thing that sits in between the model and the view and sort of adapts between them. It arbitrates, right? And here's a quote that says basically exactly that, also from the Apple docs. It's an intermediary, a conduit. It performs setup and coordinating tasks, right? So I'm like, okay, sure. But I wanted to try to figure out, like, beyond the Apple documentation, like, what other information was there out there about MVC, particularly from the people who created it? What problem were they trying to solve? Why they do it this way? So I went looking, and I found this document, a description of the model view controller user interface paradigm in the Smalltalk 80 system, which was written about 15 years after MVC was created, actually. It was created in the mid-70s at Xerox as part of the Xerox Alto prototype computer, which is what Smalltalk was also developed for. And so this is Alan Kay's group at Xerox, all this amazing, amazing stuff. You could lose weeks and weeks and weeks of your life just reading about Smalltalk and how it worked and what they were doing and all the ideas they had for how computing should work. And I get a little bit depressed because kind of living in the bad ending of that, in some ways. So I found this really incredible diagram. So I have a backup slide that's got it bigger. If you can't see it, but this projector is pretty huge, so we should be okay. So just look. This is so different looking from the one we just looked at. Like the model and the controller are like binding to each other, and like the view doesn't ever even talk to the controller. Like, what's going on with this? So after looking a little bit more, it turns out that Smalltalk MVC was really different from what we do today. Controllers handled user input, not views. That's what they were controlling. They were like responding to input and like changing things in the interface. The views had no ability to deal with like mouse input or keyboard or anything like that. The way this worked is that there was one controller for each view, and it would, when you're displaying a model object in a view, you would send it the model message along with the object, and then it would create a new instance of its default controller class you specify, and then it would just like set that as the current controller, and then when events came in, the controllers had a way of delegating control from the top down based on, by default, hit testing. And but you could override all that. So this is, again, totally different from the way it works today, where you get hit tested to some view, and then control kind of proceeds from that view back up via the responder chain. The other thing, as I pointed out earlier, is that they bound the model like directly to the view, and whenever the model changed, they just like updated shit in the view. And likewise, the controller also became an observer of the model, and reacted to changes in that. So really quite different from this sort of adapter pattern that we see in the current sort of thinking about what MVC is. So yeah, in Cocoa, our views are these controllers because they also respond to user input and are supposed to sort of arbitrate how you react to user events and what sort of state updates get made in response to clicks or taps or drags or whatever. So do controllers even exist? Like, do we need them? Well, most of the alternatives out there to MVC get rid of them. So we have MVVM, we've also got Viper, which I don't even know how to expand that acronym, but look it up, it's cool. There's actually a thing called Model View Adapter, which is essentially that diagram that we just saw from the Cocoa documentation, but they just renamed controller to adapter. It's the same thing. So I think that in a typical Cocoa application or Cocoa Touch application, you can get really far with just a really, really simple sort of, I mean, it's not even really a controller. It's more like just a model, like an application model. And what this is going to do is just say what are the possible views that you like, lowercase v views that you can have in your application. Like, am I going through the new user flow? Which subset of that am I doing? Like, am I like, which tab of a tab controller am I looking at? And it'll just instantiate and configure those views all on its own. You don't have to pass around all this stuff and inject things and thread model objects down through like 6 different layers of view controllers. And it's going to be what pushes and switches things on tab bar controllers. And this, I was happy to see that Chris presented something that looks somewhat similar to something I would do with this. And this is an example of that interpreter pattern that I was talking about before, where you define what data you want and then a way to turn that data into these side effects in the view controller system, pushing things, making other things here disappear. And there's coordination work involved, a lot of boilerplate for interacting with UIKit, where you have to become the nav controller's delegate, update your state if the user like drags backwards, and all these sorts of things. So, but it seems possible. It seems like an interesting area to explore to me, anyway. So I think that's all I have to say about view controllers. Kind of looked at what these mega view controllers are, where they come from, this arm's length coupling, which happens when view controllers can directly reference each other, and we get this sort of thread that we have to follow through our program without actually, and that's just sort of implicitly baked in there as side effects. We also learned about how view controllers are not really controllers in the Smalltalk sense, and I'll assert that we don't really need controllers. We can get away with just other sorts of manager objects or other sorts of things that set up our state and behave more like state machines or little models of what's happening. That's really all I have. Talked about stratified design. Hopefully you understand what that is, and you can maybe think about that in your own programs. When you're trying to design a system, you can go and say, how could I think of this as like a little Lisp DSL? And then you can use this interpreter pattern that we talked about to implement that in Swift. And you could also think about, want to go really hard, you could think about the difference between data in your program and an effect in of that programming language you're building. So that's what I had. Ready for questions.
Could you actually go back to the slide, the stratified design slide from the beginning? There are two parts of it that seemed similar to me, and I was curious. Yeah, so means of combination and means of abstraction. Can you explain a little bit more, like what the difference would be between those?
Yeah, sure. So the idea there is one of them, the means of combination, is a way to build up compound structure, but that's done anonymously. It's not really. You don't necessarily have to have variable names at all to be able to do that. You can just sort of substitute in different sub-expressions and just build a big tree. Whereas the means of abstraction is really about being able to do like sorry, I'm not sure where the slide is, but in the picture language, when we had like define wave 4 equals like wave, some combination of wave 2, being able to refer to these things by name is part of that means of abstraction. And being able to like isolate out a set of code that may take other elements as input, may even take other functions, like other abstract units that are parameterized as input, and those are higher order functions. So really, the means of combination is about building trees, and the means of abstraction is about being able to separate out parts of those trees into things we can refer to with a name, and that is potentially parameterized by other elements. So we can build up these combinators.
Are views?
What does it mean when those elements are views? Yeah. I don't know.
Hi, I really enjoyed how undoctrinaire this talk was about singletons, because I think they sometimes get a kind of unthoughtful and reflexive beat up, but it's worth thinking about like why they're everywhere. The ambient environment pattern you described reminds me of something called the components system enclosure. I don't know if you've run into that.
No, I haven't.
But that might be worth looking into. I mean, it's very similar in that they discover this problem that there are usually singleton-like resources like access to a database or access to a network connection or something. If you're running in the JVM, you want to be able to restart, so you don't want it to be tied to the one JVM you're in. And for testing, you want to be able to wipe it away and make a new one. So there's this pattern that's become very common of people defining basically a collection that holds all of those elements, and then explicitly creating it, and then you always pass in that tuple or hash map or whatever it is. Yeah. And then your app can get at all of those components. Yeah. And then you can blow it away and restart your whole app without having to restart the JVM. Yeah. And you can also then, if you want to, define dependencies between separate collections of ambient components and have well-defined like startup routines and teardown routines. So it reminded me a lot of that. And since you're also talking about Lisp, so I was just curious if that had been an influence or something worth looking into.
I hadn't heard of that, but that sounds really cool.
Yeah, it's a component stuff. Stuart Sierra, I think, is the guy who talks about it a lot.
And more questions? Okay, cool. Then thanks again, Colin.